Module 5, Lesson 3, has us learning to write algebraic expressions. If I'm guessing right, that means they're going to be giving us some words, and we've got to take those words and write them into mathematical problems. Content objective, students will write algebraic expressions, and they're claiming that this too will be a 2-day lesson. Now we're going to take and start off with variables and what they are. Variables represent unknown values of an expression. They represent some number, but initially you don't know what that number is. You may end up finding out what that number is later on by solving, isolating your variable, or you may never actually find out what the variable represents. Depends on the problem. Algebraic expressions use variables to represent values that are unknown or can be changed. For example, the expression that represents the area of any figure contains variables. In the late 1500s, Francois Viette introduced variables to name unknown mathematical values. Everybody wants to know what mean, horrible person it was that introduced letters into math. This is him, Francois Viette. And for example, he came up with the idea that 3 times as many items would mean 3 times A. Variables were represented with uppercase vowels in his notation. Now today the most common variable is X, but okay, we're good with that. In 1637, a fellow by the name of René Descartes popularized the use of variables and the notation that we also use today. He used letters at the end of the alphabet, such as X, Y, and Z, to represent the variables in his work, and that X, Y, and Z, those are a whole lot more common today than a capital A is for variables. Some variables have specific uses. For example, L we always use for length, H we always use for height, and W we always use for width. A big A right over here, that large A, that's always used for area, and the large V, that is always going to be used for volume. Our inquiry question says, how can you represent situations using words and symbols? And look at that pretty artwork they have, which really means absolutely nothing to their question here. Now the book is going to give us a video on using algebra tiles to represent mathematics. So here we go.
Using algebra tiles. When using algebra tiles, positive X tiles are green and positive 1 tiles are yellow. Red tiles represent negative values. A red rectangle has a value of negative X, while a red square tile has a value of negative 1. 3 positive 1 tiles represent the integer positive 3. And 5 negative X tiles represent the term negative 5X. A pair consisting of a positive 1 tile and a negative 1 tile is called a zero pair. These tiles cancel each other out to result in a value of 0. The same applies to X tiles.
Well, okay, let's see if they're going to let us actually play with some algebra tiles in this lesson. Jose, Valerie, and Letitia work at a bakery. Each week, Letitia works 2 more hours than Valerie. Jose works 3 more than twice the number of hours Valerie works. Well, that's kind of complicated, isn't it? Which tile would you use to represent the number of hours that Valerie works? Represent your reasoning. Well, let's go back and look at our problem here. Does the problem ever tell us how many hours Valerie works? It does not. Valerie is the unknown element in this. We can't say that she works 1 hour because it never says she works 1 hour. All we know is that she works some number of hours, and that unknown number of hours, we're going to represent that with the variable X. Now, if one X tile represents the number of hours that Valerie works, we're going to use a tool to represent the number of hours that Letitia works, and then write an expression using numbers and variables for the tires. We know right here Letitia works 2 more hours than Valerie does. So that's going to be an important part of the problem. We know that Valerie works X hours. We also know that Letitia works 2 more hours than Valerie does. So that's going to be our representation using the algebra tiles. Valerie's hours plus 2, that's going to equal to Letitia. Now the next part, I think they screwed up because they repeated the same exact question where they're talking about Letitia and Valerie, but I think they really wanted Jose for this, so that's what we're going to do. We know that Jose works 3 more than twice the number of hours that Valerie does. So to do that, we're going to take and first highlight Jose's part here. So he works 3 more, so that's going to be 1, 2, 3, than twice the number of hours that Valerie works. So Valerie works this, so if we have 2 of the Valerie hours plus 3 more, we're going to find out that Jose, he's one hard-working cat. Now to finish this up, we're going to take and combine our tiles to model how many total hours that Letitia and Jose work together. And I'm going to do these a little bit different this time. I've got Letitia was Valerie plus 1. Jose was twice Valerie plus, what was that, 3? 1, 2, 3. So how are we going to work these together? Well, how many x's do we have? We have 3 x's and 1, 2, 3, 4. So the answer for, whoops, where did that other one go? Let's bring it back down here. The answer for how many hours would they work together would be 3 times Letitia's hours plus, or is it Letitia? I'm sorry, 3 times Valerie's hours plus 4 would represent how many hours that Letitia and Jose work together. If we wanted to figure out how to write it with everybody working, how many hours they all work together, all you'd have to do is go back to what we had here before, which apparently it erased, and add 1 more for Valerie. So now we've got Valerie, we've got Letitia, and we've got 1, 2, 3, and I'm not 3. I'm sorry, that last one doesn't belong there. And the 2, and then 1, 2, 3 for Jose. So you could say then that the answer for all of them together would have been 4x plus 4. That would represent the hours that all 3 of the employees worked. But I think we've spent enough time playing with blocks. Now we're going to take and actually start applying this to numbers and variables. Algebra is a branch of mathematics that uses symbols. That sounds like a vocab word, term right there. I think we might even have that one in our list. Let me see. Well, would you looky right there? The first definition I have listed for this lesson is algebra. Of course, you're going to have a lot more definitions than that on your upcoming vocab quiz, but that's the first one. A variable is a symbol, usually going to be a letter that is used to represent a number. That's going to be another vocab term. And let's go ahead and make that vocab green since we know it's vocab. And then an algebraic expression is a combination of variables, numbers, operations, that means add, subtract, multiply, and divide, and grouping symbols. Those are going to come together for your third definition, which is algebraic expression. An example of an expression would be n plus 2. And it represents a phrase of the sum of some unknown number and 2, and in this case n is a variable. Any number can be used as a variable. We generally like to use x or y or z, and but we don't always use those. It varies. To avoid confusion with x as a multiplication symbol, we now are going to be starting to show multiplication other ways. From this point forward, anytime you have a variable in a problem, an algebraic expression, you can no longer use x, the cross symbol, to represent multiplication. As you can see right here, you can use the dot, 5 dot x is 5 times x. You can use the parentheses. 5 parentheses x is 5 times x, and you don't even have to put anything between them if it's a number and a variable, or a variable and a variable. 5x, that means 5 times x. For division, you would use 5x divided by, using the vinculum 3, or you could write it as a fraction, 5 times x on top with 3 in your denominator. And then if you wanted to do 5 times double the value of x, that would be 5 here times with a dot 2x, or 5 times in parentheses 2x, or you could do 5.2.x, or what's 5 times 2? Well, that's going to be 10, so you could call it 10x. Now we're going to learn a whole bunch more of our vocabulary words that are going to be coming up on our upcoming vocab quiz. The first one is going to be terms. Each one of those values is a term, and a term is going to be something that is separated by an addition or a subtraction sign. When addition or subtraction signs separate an algebraic expression, each part is called a term. Unfortunately, these I cannot highlight for you. Like terms are going to be that. The 4x and the 2x are like terms because they contain the same variables to the same power. They both contain an x to the first power, and of course we don't see the 1 for the x there, but they both contain an x to the first power. The coefficient, that's going to be the 4 and the 2. Your coefficient is going to be the numbers in front of variables, and of course your variables, those are going to be your x's. Finally, the last word we're going to pick up here is constant, and the constant is a term without a variable. A whole number, a fraction, a decimal, if it does not include a variable, it is considered a constant because it is constantly the same number. This is constantly 12. It will never represent any number other than 12. It will always be 12. Now we're going to learn to identify terms, like terms, coefficients, constants in the expression. We've already discussed them. We're going to dig a little deeper in there. It says, how would you begin to identify the parts? Well, I think I would personally start looking for the terms, the things that are separated by an addition and subtraction, and that is exactly what they did. 6n is a term, 7n is a term, 4 is a term, and 2n are terms. So it says highlight the like terms now. Well, the like terms are going to have the same variable to the same variable to the same exponent. So that, and that are all going to be like terms. They all are have a number multiplied by n with just a 1 or really nothing above it. But there's an invisible 1 there. So that part's good. Next, drag the coefficients and the constants of the terms to the appropriate bin. Well, the only constant we have is 4. 4 is constantly going to be 4. Your coefficients are going to be the numbers attached to variables, so the 6, the 2, and the 7 are all going to be coefficients. Now it's going to be your turn to take and identify the different parts of this. Identify the terms, the like terms, the coefficients, the constants in the expression 9y plus 4 plus 11y plus 7, and drag the correct identification into each group. Go ahead and pause the video and do that. Did you get them all right? First thing I'm going to look at is the 4 and the 7 are constants. They're off by themselves, so I'm going to drag that into the constant spot. Your coefficients, those are going to be the numbers in front of your variable. So I have a 9 and 11. Those are going to be my coefficients. That's going to go right there. And now I have terms and like terms. Well, the terms are going to be the things separated by an addition or subtraction symbol. All 4 pieces of that are going to be terms, so they're all going to go there. And then the like terms, well, actually, nope, that one's going to go there. My bad, because I have an and here. Your like terms, 4y and 11y, those are going to be the like term. 4 and 7, those are also going to be a like term. Even though they don't have a variable, they are alike in the fact that they don't have a variable. Therefore, they're going to be like terms as well. Check our answer. Everything checks. We're going to make this the last slide set before we go on to part 2. So we're going to start off by selecting each card to see how to write variable phrases of algebraic expression. And it says, when defining a variable, choose a variable and decide what it represents. They don't really say what defining a variable is here, but if we go back to our vocab sheet, and that vocab sheet is on the very top of this module in your module section on Canvas, it says defining a variable is the act of choosing a variable and deciding what that variable represents. Defining a variable. So with that, we can go here and say in words that describe the mathematics of the problem. Okay, well, let's see here. Okay, so in words, we want to describe the mathematics of the problem. And then variable, we need to define a variable to represent our unknown quantity. And then for an expression, we're going to translate those words into an algebraic expression using the variable that we already came up with here. In order to translate a situation into an expression correctly, though, it's really important that we understand what the different operations mean as words. So we've got these words here, and we need to find out what box they go in. Product, well, that's the answer to a multiplication problem. The quotient, that's the answer to a division problem. Sum, that's the answer to an addition problem. And then we have less than a number. Less than a number suggests subtraction. And increase by, that suggests addition. And with that, we are going to bring an end to part 1. Come back in just a little bit and watch part 2 so you will be well versed in everything you need to know so that you too can write algebraic expressions.